So let's start. It's been an entire year, well, a calendar year anyways. Happy New Year to you, of course. We're looking at the idea of and if you wanted me to summarize and in one sentence, and means multiply. And means multiply. If you want to find the probability of one thing and another thing occurring, you multiply the probability of the first one times the probability of the second one. In fact, that gave us our little formula here. We said that as a formula, the probability of A and B occurring, it's the probability of A times the probability of B given that A had occurred. This vertical line here was an abbreviation. It meant given that. And what we really meant was you had to make sure you were using the correct branch of the tree. For example, we looked at situation 1 where you were picking a ball out of a pot without replacement. So we said on your first draw, you had a 2 out of 3 chance of getting a white ball and a 1 out of 3 chance. And on your second draw, well, it depended on whether you had a white ball in your hand to begin with. We said that these were dependent events because the odds, the probability, the fractions, the tree branches changed depending on which branch you went down. So we said that A and B are dependent because the two bottom forks are not identical, or the probability of B given A is not the same as the probability of B given not A. We said that this branch and this branch were not identical. It depended which event happened before. We're going to get more into that later. Oh, we also said, by the way, if you wanted to, you could get B given A by itself by dividing both sides by probability of A. That's going to become important in the next lesson. We left off on example 3. Okay? We left off on example 3. And what I'm going to be starting to do for the next couple of days, Christina, is giving you strategies. I see a little hand up there. Let's keep going here. Example 3. Justin, can you read to me example 3, please, my friend?
Yeah.
That's also my way of making sure you found where we left off.
Yeah. 3 cards are...
Sorry, how many cards?
3.
Now I got to stop. I'm going to try and give you strategies starting today. 3 cards. I may or may not use a tree. In fact, in a couple of lessons, I'll show you a strategy for 3 cards or 4 cards or 5 cards for poker hands. And we're not going to use a tree because the tree would get huge. You would pick 1 card, pick another card, that's 3 cards, pick another card, that's your tree would get huge and wide and it would become unwieldy. 3 is kind of my tipping point. Sometimes with 3 cards, I'll use a tree as my strategy. Sometimes with 3 cards, I'm going to use combinatorics from last unit. We'll talk about that. Keep reading. Start from again.
3 cards are drawn without replacement from a shuffled deck of 52 cards.
Gotcha. Keep going.
What is the probability that all 3 are spades?
You know what? Since all 3 events are the same, spades, 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 I am going to use a tree, but I'm not going to draw out the whole tree. I'm only going to draw out the branch that I'm interested in. I'll show you what I mean. Put your pencils down for a second. See, if I was doing a tree, I would go like this. I would say, okay, spades on the first, not spades on the first. Spades on the second, not spades on the second. Spades on the second, not spades. You know what? That's very, very, very unwieldy. I'm not going to bother drawing this branch, the not branch, because Christina, it's not happening. It says all 3 have to be spades. I'm going to be a bit lazy here. So you ready? We're just going to pick up your pencils, draw the branch that we're interested in. I'll use S for spades. I'll use S1 for first cards of spade, S2 for second cards of spade, S3 for third cards of spades. So here's just the only branch, the single branch that I'm interested in. How many spades are there in the deck? Out of 52. All right, that's the first card. What's the second card going to be? A spade again. Right? How many spades are there in the deck? Careful. Now 12 out of 51. Pick the third card. I want it to be a spade as well. How many spades are there in the deck? out of. So the probability of spade 1 and spade 2 and spade 3 is, what does and mean? Multiply. It's going to be 13 out of 52 times 12 out of 51 times 11 out of 50. And those of you who are really observant may notice that the top goes 13, 12, 11. Maybe there's a way we can write that with factorial notation. We will in a couple of days. And you may notice, Jordan, that the bottom is going 52, 51, 50. There is a way to write that with factorial notation. We'll look at that in a couple of days as well. Meanwhile, let's get an answer. To multiply fractions, that's the easiest. It's top times top times top over bottom times bottom times bottom. So get your calculators out. What is 13 times 12 times 11 on the top? 1,760? 16? 1716? Over, what is 52 times 51 times 50? 132. That's not in lowest terms. And if you want to get it in lowest terms, of course, you have a nice easy way to do that. You just go 1716, fraction button. Remember, this is our fraction button right here. 1,32600. Oh, that didn't type right, Mr. Dueck. 1,32600. And in lowest terms, it's 11 out of 850. Or as a decimal, 1.3%, because 0.01 is 1%, so 1.3%. The odds of getting 3 aces in a row, not great, because that's a good poker hand. So the probability shouldn't be good, shouldn't be high. What does and mean, Sean? Multiply. In fact, if you're doing a tree, the rule is you multiply down the tree, you add across the tree. Multiply down, add across. We'll talk about that as well. Let's do a few more. Example 4. Randomly select one bill from pot A and one from pot B. How many selections are we doing grand total? 2. A tree will work nicely. It'll be a 2-level tree. I can do that. If I was picking 4 or 5, I would not use a tree. I would be using strategies coming up in a couple of lessons. But for now, 2 tree. So my tree is going to look like this. It's going to have 2 levels. On the first level is going to be whatever I got in pot A. Now, what can I get in pot A? What are my possibilities? What are my outcomes? So it could look like this. You can get a 0, a 10, or a 20. Those are the possibilities for level A or pot A. What's the probability of getting a 0 from pot A? What's the probability of getting a 10 from pot A? 1 out of 3. What's the probability of getting a 20 from pot A? 1 out of 3. By the way, remember the built-in error check? The built-in error check is if I ever add across all the branches, what should it add to always? Do you remember? I heard it. Someone said it. To 1. Okay? Is 1/3 plus 1/3 plus 1/3 1? So I didn't miss anything. Now let's go to level B. It looks like I can get 1, 2, 3, 4 possibilities, 1, 2, 3, 4 possibilities, 1, 2, 3, 4 possibilities. Oh, wait a minute. 2 of those possibilities are the same, Mr. Dueck. Don't do 4. There's 2 10s, yes? So instead, let's go 3 possibilities. And we'll use a weighted. We'll weight each branch with the probability. And what I mean by that is, okay, looking at pot B, what's the probability of getting a 0? How many zeros are in the pot? 1 out of? Okay. And that's a 0. You can get a 10. You can get a 20. What's the probability of getting a 10? 2 out of 4. And 1 out of 4. Double check, do those all add to 1? Yep, I didn't miss anything. You can get a 0, a 10, or a 20, a 0, a 10, or a 20. And again, it's 1 out of 4, 2 out of 4, 1 out of 4, 1 out of 4, 2 out of 4, 1 out of 4. Is that okay, Silka? By the way, Silka, do you notice that these 3 branches are identical to these 3 branches are identical to these 3 branches? That means these are independent. Because it didn't matter what event happened for pot A that had no effect on the odds of pot B. These are independent events. What happened before didn't affect what happened afterwards. Which makes sense. What you picked in the first jar has no effect on what's coming out of the second jar. Of course, they'd be independent. They don't affect each other. Cards are almost, especially if you're not replacing, cards are going to be dependent because what you have in your hand determines the probability of what's left in the deck because you might have the card that you're looking for in your hand already, or you might not. So, pardon me? Is this, yeah. Sean, what's event A? What does A want us to find?
A $10 bill on each draw.
On a $10 bill on each draw. Which branch is that? Look at my tree. Which branch would be a $10 bill on each pick? Huh? You're right. What? I think it's this one right here. Isn't that a 10 on the first, a 10 on the second? Okay, so if I was going to write this in probability notation, it would look like this. The probability of a 10 from pot A, how about a 10 with a little A down there, comma, because a comma in English replaces the word and, yes? A 10 from pot B. So what's the probability of getting a 10 and a 10? What does and mean? Multiply down the branch. I think it's going to be 1/3 and 2/4. I don't need a calculator for this. Multiplying fractions is the easiest operation. Top times top. 2 over bottom times bottom. 12. Or in lowest terms, what is 2 over 12? 1/6. Okay. You've got a 1/6 probability of winning 20 bucks playing this game. Sorry, of winning 2 10s. There may be other ways to win 20 bucks. Jordan, can you read B to me, please, my friend?
$10 bill on only one of the 2 draws.
Okay, a $10 bill on only one, so 10 and nothing. Which branch or branches are those? I think we're talking this branch right here. Yes? And this branch right here. Okay? Now, in terms of a tree, it's going to be 1/3 times 1/4 plus 1/2 times 1/4 because it's multiplied down, add across. But let's do it in probability speak. Here's what this is really saying. Probability of, let's do it right. 0 and 10. That's one possibility. Or probability of get a 10 followed by a 0. What does or mean? What does or mean? Add. What does and mean? Multiply. So let's multiply down the branch that has a 0 from A and a 10 from B. That's going to be 1/3 and 2/4. Or let's multiply down the branch that has a 10 from A, 1/3, and a 0 from B, 1/4. Is that okay, Brooke? Multiplying fractions is the easiest. Top times top, bottom times bottom. I think we're going to end up with 2/12 or 1/12. This is why I said we never bother reducing fractions, because adding fractions, Emma, I need a common denominator, but you may notice that I already have a common. This is why I didn't want to change that to sixth. Hey, 2/12 and 1/12 is what? 3/12. Which I guess in lowest terms is 1/4. 25% of the time, 1 out of every 4 times, in theory, you'll get exactly one $10 bill and nothing. So Rosanna, you can think about it both ways. In terms of the tree, multiply down, add across. Oh, by the way, or actually means add minus the overlap. But because of the way I've set up this tree, there will never be an overlap because I've carefully separated out all the branches. So I can kind of be really, really sloppy. I'm using the or equation from our pink sheet, Brooke, but I'm simplifying it even more. I'm saying because I set up the tree so there is no overlap, or means add. And means multiply. Or multiply down the tree, add across the tree. Example 5. A die is rolled 3 times. What's the probability of getting a 5 on all 3 rolls? 3 5s in a row. Well, if I wanted to write that, I think we're saying this. What's the probability of getting a 5 on the first and a 5 on the second and a 5 on the third? Right? 5, 1, 5, 2, 5, 3. You can come up with your own notation, but Caitlin, try and be clear so that when you look later on, you know what the heck each thing stands for. So I'll often put as a subscript the event number and as a big thing, whatever the event is. How many rolls? Tree, maybe. I told you, Justin, that 3 events, 3 rolls, 3 cards, 3 marbles, 3 picks, 3 whatever. That's my tipping point right there. Sometimes I'll do a tree and sometimes I won't. I'll do a tree if the events are all the same. Are the events all the same here? What's the first event? Rolling a?
5.
What's the second event? Rolling a?
5.
What's the third event? Rolling a?
5.
Are the events all the same here?
Yeah.
Yeah. You know what? I think I can do a tree. You know what? I'm going to do the same trick I did with that ace. I'm just going to do the single branch of the tree. I'm going to say, okay, what's the probability of rolling a 5 on the first roll? 1 out of 6. What's the probability of rolling a 5 again? 1 out of 6, because they're independent. What you roll has no effect on what comes after. What's the odds of rolling a 5? What's the probability of rolling a 5 again? Now you understand this tree would be very, very unwieldy if I tried to draw the whole thing, because I should have, Rachel, 6 branches on level 1, right? 1, 2, 3, 4, 5. And then from each of those 6 branches, 6 more branches for the second row. And from each of those, 6 more branches for the third. I think it's going to be 6. I think you'd have 216 branches. Ugh. But because it's the same event, Sean, over and over and over, I'll just draw the one branch that I'm interested in. What does and mean? So you know what? I think it's going to be 1 6 times 1 6 times 1 6. You guys have asked when you're rolling the dice of fate, sometimes you have noticed we get the same number several times in a row. What's the probability of that? Well, in this case, getting 3 5s in a row would be 1 6th, 1 6th, 1 6th. I think I can do this in my head because the top is going to be 1 times 1 times 1. Cool, in your head without a calculator. What is 1 times 1 times 1? 1? How about yeah, okay, 1. 6 times 6 times 6, you may need a calculator for, I think it's 216, but double check me. It is? Okay. Or if you've wondered, hey, what's the probability of rolling 3 6s in a row? If I have 3 students come late, what's the probability that all 3 roll 6s? It's 1 6 times 1 6 times 1 6. It's 1 in 260, which means it won't happen very often. Can't. By the way, it could happen 10 times in a row. All this suggests is the theoretical probability, but sometimes people beat the odds. Okay. B. I like B, I like B, I like B. B is a nice question. Kyla, can you read B to me, please? At least 1 5. What does that mean? That means 1 5 or 2, Rosanna, or? Now, here's how complicated this is, though. That means you can get 5 on the first, something else, or something else, 5 on the second, something else, or something else, 5 on the third. That's all the ways you can get 1. Or, to get 2, you can get 2 on the first, 2 5s in a row and nothing, or a 5, nothing, and a 5. Or there's like, I think there's 16 possibilities. Wait a minute. What did I say as a hint? What did I say as a hint? Jacob, what did I say? Read that to me. What did I say as a hint?
At least.
No. What did I say as a hint?
Think complement.
What's the complement? The opposite. What's the opposite of getting at least 1 5? Think very carefully. What's the opposite in English of getting at least 1 5? What's the opposite of getting at least 1 5? Jordan, remove the word at least. No 5s. Okay? The complement to at least 1 is none. So, we're going to do it this way. The probability of at least 1 5, which means 1 or 2 or 3, or meaning add, but you saw there's all these different possibilities and how I can mix and match those. Yuck. It's 1 minus the probability of no 5s. This is the complement. This is where the complement comes in handy. I said to you, sometimes, Rachel, it will be easier to figure out the probability of something not occurring and then go 1 minus that. That must be the probability of something occurring. Because not and happening always have to add to 1. That was equation, whatever, 4, I think it was, on your sheet, the idea of the complement. The probability of A plus probability of not A always have to add to 1. And this is much easier to do because, ready? How many times are we rolling? 3 different times. Let's see if we can just figure this out. Now this means 1 minus the probability of not a 5 on the first, not a 5 on the second, not a 5 on the third. And remember that horizontal bar, K1 is our abbreviation for not. All right. What's the probability that you don't roll a 5? And what's the probability that you don't roll a 5 on the second roll? And what's the probability that you don't roll a 5 on the third roll? One minus, oh, I remember 6 times 6 times 6 is 216. What's 5 times 5 times 5? 125? You know what? Let's keep going without a calculator just to see if we can. Now, Erica, subtracting and adding, I need a common denominator. So I need to make that 1 I need to write it as a fraction over 216. Ellen, you're right. What? 1 is going to be 216 over 216 minus 125. You know what? It's going to be whatever 216 minus 125 is. 91? Double check me. Got your calculators? Double check me. Is it 91? Yeah? Woohoo! So the probability of, if I have 3 kids late, at least one of them rolling a 5 is that. Or instead of a 5, probability of at least one of them rolling a 6 is that. Hey, Mr. Dueck, what if you wanted to find the probability of them rolling a 5 or a 6? Did I say or? What does or mean? Find the probability of at least one 5, find the probability of at least one 6, add. Okay. Good yawn? Turn the page. Oh, I know. I can spot it. Okay. Connor, my friend, can you read to me this next example? Stop. How many cards?
2.
I think I'm going to use a tree for 2 cards. Keep going.
Drawn without replacement.
Okay, without replacement means it's going to be dependent. The branches, the fractions are going to change on the second level depending on which branch I go down on the first level. Okay? From a standard deck of 52 cards, find the probability. What does A want us to find?
Both cards are black.
Okay, if I wanted to write that in probability notation, it's saying this. Find the probability of black on the first, black on the second. Let's do our tree right here. So we can have black, not black. How many black cards are there in a deck of cards? It's half of them, yeah? 26 out of 52 and 26 out of 52. Then we have, sorry, I should have put a 1 here, not a 2. Then we have black on the second, not black on the second, black on the second, not black on the second. Ooh, careful. So down this first branch, we picked a black card. How many black cards are now left in the deck? 25 out of 51. How many non-black cards are left in the deck? Still 26 out of 51. Fill in the right-hand branch. Here we didn't pick a black card, picked a red card. So how many black cards are left in the deck? Out of 51 and 25 out of 51. Again, notice, don't write this down, this and this are different. B2 is different depending on which branch you went to. On one branch, it's 25 out of 51. On one branch, it's 26 out of 51. That means these two events are dependent, not independent. Connor, what was the event for part A?
Both cards are black.
You know what? I think that's that branch there, is it not? Okay. It's black with the first card and black with the second card. What does and mean? Multiply, or it's multiply down the branches. No matter what, it's going to be 26 out of 52 times 25 out of 51. 52 times 51, I'm pretty sure, is 2652. I've done that one a whole bunch of times, and I've eventually memorized it. What's 26 times 25? Well, 24 times 25 would be 600, 650? Is that all right? B. Rachel, can you read B to me, please? How many cards? How many cards are we picking? Tree. So, spade, not spade, spade, not spade, spade, not spade. How many spades are there in the deck? 13, 1/4 of the deck. So how many not spades are there? Do the arithmetic. 39. Now, down the left-hand branch, we picked a spade. So how many spades are left in the deck? Hello? 12 out of 51 cards left in the deck. How many non-spades are left in the deck? 39 out of 51. Now down this branch, we didn't get a spade. Okay, so how many spades? 13 out of 51 and 38 out of 51. There's my tree. What's this question asking me to find? Well, it wants the probability of not a spade followed by not a spade. See the branch? Sean, what times what? 39. I know that 52 times 51 is 2652. I have no idea what 39 times 38 is. Well, 40 times 40 would be 1600, so it's going to be somewhere in the 14 or 1500s, somewhere. I'll tell you. 1418, 82. Sorry. Getting the hang of this, Rosanna? As you're smiling away at some private joke? No, you're smiling because you're finding this so interesting and fun, aren't you? Of course you are.
I always smile.
Of course you do. Speaking of, Rosanna, can you read C to me, please?
First card is a queen. And the second card is a king.
Okay, you know what? This one, I think the order matters a bit. And this is a tricky one. Okay? This is a tricky one because why? Well, what does the second card have to be, Rosanna?
3.
That depends then on whether or not the first card is well, wait a minute. I know what the first card has to be. What? Okay. I think we can do this one without a tree. Let's see. If I write it as a formula, it would be this. Find the probability of a queen on the first and a 3 on the second. How many queens are in the deck?
4.
Out of? So let's suppose I picked one. How many 3s are in the deck? 4 out of? Careful. I think if you drew the tree, that's what it would look like. I think it's going to be 16 over 2652. How is D different from C? Okay. D is going to be a more difficult question. D is going to be a more difficult question because you can get a 3 or a queen on the first draw, followed by a 3 or a queen on the second draw, but don't get 2 3s in a row and don't get... I think we're going to have to do a 3-branched tree. I think my tree is going to look like this. Queen on the first, 3 on the first, other. Queen on the second, 3 on the second, other. Queen on the second, 3 on the second, other. And Rachel, I'm not going to bother filling in this branch because it's already a loser. I'm not going to do a full tree here. In fact, can you see which branches I'm interested in? Brooke, I think I'm interested in this branch where I get a queen followed by a 3, or this branch where I get a 3 followed by a queen. Everything else is no good according to this question. Is that okay? I think if we put the fractions just on those branches carefully, I think then it's going to be multiply down, add across. It's going to be or means add. So let's fill in these. How many queens are there in the deck at the beginning? What fraction is going to go right here? I can't hear.
4.
That's not a fraction.
That's not a fraction. 4 is not a fraction.
Well, it is, but out of what?
4 out of 50.
Okay. So 4 out of 52. How many 3s are there at the beginning? Also 4 out of 52. I'm not going to bother filling in the other branch. I don't care. So my error check this time, Caitlin, of making sure everything adds to 1 isn't going to work because I'm not doing the complete tree. Down this first branch, you got a queen. How many 3s are left in the deck? Down this first branch, you got a queen. How many 3s are left in the deck? 4 out of 51. Down this second branch, you got a 3. Now we want to do the queens. How many queens are left in the deck? Out of? You know what? I think it's going to be this branch or that branch. I think it's going to, so the probability of a queen and a 3 in any order is going to be 4 out of 52 times 4 out of 51, or 4 out of 52 times 4 out of 51. Now, I am noticing that these numbers happen to be the same. That won't always be the case. So I can't say, oh, they'll always be the same. It's going to be 16 out of 2652, or 16 out of 2652. It's going to be 32 out of 2652. A few more, we're done. Turn the page. All right. What if we give you questions where we don't tell you the events, we don't say what they are, we just give you the probabilities? Well, then you have to use the formula. And what's the formula? A and B equals the probability of A times the probability of B given A. As an example, suppose the probability of A is 1/2, the probability of B is 1/3, and the probability of A and B is 1/4. Find the probability of B given A. Say what? This is our formula. We haven't used the formula, we've turned it into trees, but that's what the trees came from. It said and means multiply. Jordan, what's this question asking me to find?
Find probability of
B. What's that vertical line mean? You need to know this. Okay, so given A. It wants me to find this. Jordan, you're in physics?
Yep.
How would I get that by itself? How would I move this over?
Move A over.
Yeah.
Divide.
Why? Okay, we're multiplying, so if I wanted to get this by itself, I would divide this over. In other words, I think what you're saying, Jordan, is the probability of B given A is going to be the probability of A and B divided by the probability of A.
Yes.
Did they tell me the probability of A and B in the question? Did they tell me the probability of A in the question?
Possibly. Yes.
Where?
What are the two?
Right? You clue it in, yeah? Yeah. Okay, it's going to be 1/4 divided by 1/2. How do you multiply fractions? That's the easiest one. Top times top, bottom times bottom. How do you divide fractions? Because that's what we're doing here. Don't need a common denominator. Only need a common denominator for adding and subtracting. How do you divide fractions? Was that a hint? Do you remember? It's Math 8, technically. And it's your generation sucks at fractions, I realize that. I heard someone say the word multiply. That's part of it. Yeah?
You multiply it, top to top, bottom.
No, that's multiplying is top times top, bottom times bottom. Yeah?
Do you multiply when you flip the second fraction?
There's a fancy word for flipping a second fraction. It begins with the letter R. You multiply by the reciprocal. 1/4 divided by 1/2. That's the same as 1/4 times 2/1. Oh, and I know how to multiply fractions. Top times top, bottom times. Hey, what is 1 times 2? What is 4 times 1? Hey, this is using the formula. This is, okay, what if they don't give me the actual events? What if they just tell me the probabilities? Physics, this is formula manipulation for those of you who are in physics with me. Ooh. Christina, what's B asking me to find?
The probability of
A what? What's that vertical line mean? Help her out, folks. What's the vertical line mean? Given that B has occurred. Okay? Okay? It looks like what they've done is they've just switched these two letters around. They've just switched these two letters around. Do you want to solve the probability of A given B? That's going to be the probability of A and B divided by the probability of B. It's almost exactly the same equation, except here the given was A, that went on the bottom. Here the given is B, that goes on the bottom. We're going to do a whole lesson on this, so don't freak out, but I'm sneaking it in right now. Colin, did they tell me A and B? What? Did they tell me B? How do I divide fractions? That's going to be the same as 1 over 4 times 3 over 1. Question, Ellen? Sorry? Good. Apparently, the probability of A occurring given that B has occurred is 3/4. So when B occurs, A also occurs 3/4 of the time. Oh, and the probability of B occurring given that A, so if A occurs, B occurs half of the time. That's really what we're saying with that whole idea of given that. I don't know what events these are. I just made up some numbers. What does C want me to find? Or. What does or mean? Add minus the overlap. Right? So or, and this is right from your formula sheet. I think it was formula number 6 or 5. I can't remember. It's going to be A plus B minus the overlap. Did they tell me the probability of A? What? 1/2? Did they give me B? 1/3? Minus, did they give me the overlap? Sorry? 1/4? What does or mean? Add. Oh. Can I just add these? Oh, no. Adding and subtracting, Kayvon, I need a common denominator. I got a 2. I got a 3. I got a 4. What would my common denominator be?
12.
So it's going to be 6 out of 12 plus 4 out of 12 minus 3 out of 12. What is 6 plus 4 take away 3? Put your pencils down. Pick your graphing calculators up, please. Get your graphing calculator up. See this line right here? 1/2 plus 1/3 minus 1/4? 1 fraction button half plus 1 fraction button third minus 1 fraction button quarter is 7 over 12. For those of you who suck at fractions, yes, this will do the fractions for you. Okay. Kyla! Let's do this question together. This will be our final one. Kyla, I wasn't thinking of you. I was just making up random numbers, but the probability that Kyla will pass math this semester is 0.75. It's higher than that in real life, but Kyla, I wanted to make up some interesting numbers, okay? And the probability that she'll pass English is 0.9. Her English is more gooder. Assuming these events are independent, find the probability that she will pass, okay. How many different subjects are there in this question? 2. How many events are there in this question? 2. This is a job for a tree. 3 subjects? Maybe not. 4 subjects? Probably not. 2 subjects? Tree. And I'll do the tree off to the right here. I left room. I think we have room. So it's going to look like this. Kyla can pass math or not. Pass English or not. Pass English or not. So Kyla, this branch would be you flunk everything. This branch would be you pass everything, and the two middle branches are you pass one and fail the other. Kyla, what's the probability of you passing math according to this question, not in real life? Because in real life, of course, there'd be ones on all the branches of passing and zeros on all the branches of failing, and this would be a boring question. But for the purposes of argument, Kyla, what's the probability that you pass math? Going down, apparently. Sorry, what? 0.7, yeah, probability, maybe I made it a little high. No, 0.75? Kyla, so if there's a 75% chance, 0.75, that you pass math, folks, what's the probability that she fails math? 0.25, because they got to add to 1. And Kyla, what's the probability that you pass English? 0.9. What about that you fail English? 0.1. Now, this question, Rachel, says these events are independent, which means this is also going to be 0.9 and 0.1. It means the probability of her failing math doesn't affect whether or not she fails English. I'm not sure that's true in real life. I think in real life, if you fail one subject, you're probably more likely to fail more than one subject, but I was just making up numbers. Okay? Kyla, what's the first event? Roseanne, you with me? You're not looking at your phone or anything foolish like that? That would be silly. Thank you, Rosanna. Kyla, what's the... A. Can you read A to me, Kyla? Which branch is that? Oh, and it's multiplied down. You know what? It's going to be whatever 0.75 times 0.9 is. What's that, folks, on your calculators? What's the probability that she passes both courses? Point what? 0.675? Math or English. Okay? That means one or the other or both. That means, look up, this branch or this branch or this branch. Because or means one or the other or both. You know what? There's a faster way to get that. I could multiply down, multiply down, multiply down, add, add, add. Can anybody see a faster way to do that? Subtract what? Okay, I'm going to go like this. It's going to be 1 minus the probability of no, because won't that give me what's left? And that's a little less work. It's going to be 1 minus 0.25 times 0.1. What's the probability that she passes at least one subject? Because that's what really that means. Hello? 0.975? C. Math, but not English. Which branch is that? Math and not English, right? Which I think is going to be 0.075. Double check me. Yep. Neither math nor English. What's the probability that Kyla flunks everything? Oh, Kyla. Well, that's going to be not math and not English. It's going to be 0.25 times 0.1. Now, Kyla, this is kind of a stupid example in terms of you're going to pass everything. But I wanted to give you a two-level independent tree. Hey, instead of this, let's suppose you're an insurance company and you're looking at a house, let's say, in a flood area. You know the probability of a flood occurring in the next 100 years is 0.75. The probability of it not occurring is 0.25. Oh, and you know the probability of another disaster is 0.9 and 0.1. You can start to then calculate the probabilities of disasters happening. Now you know how much to charge for insurance to make sure that, in all likelihood, you don't go broke. You always want to, as an insurance company, I want to charge a little bit more than necessary, but I don't want to charge too much, because if I charge too much, Emma, you'll go to a different company. Right? It's a big balancing act. This is called Actuary Mathematics, where they look at all sorts of statistics, and the idea is, if I'm an insurance company, I want to make enough of a profit not to go belly up, and I have to be able to survive that 1 in 100 year storm, where I'm suddenly going to be paying out a bunch of money. But I don't want to just charge gazillions of dollars, because then, Caitlin, you're not going to insure with me. You're going to go to a cheaper company. So it's a big mathematical balancing act. Or you can look at health statistics and turn this into a tree. Probability of getting cancer, not getting cancer. Probability of getting a disease, not getting a disease. This has huge implications. So that's and. And means multiply. What's your homework? I have a handout for you. Homework. Yeah, 1 is good, 2 is good, 3, 4 is good. You know what? I think every one of these questions is fair game. Okay? You got the remainder of class.